Indonesia has about 127 active volcanoes. Some of these volcanoes have produced large caldera-forming eruptions, like the 1883 eruption of Krakatau and the 1815 eruption of Tambora. These eruptions were huge. They had impacts across the globe, but there was no one around in 1815 or 1883 with a seismometer to record what was happening. And so this is why using crystal records and geology is really important, because it allows us to reconstruct the processes before geophysical equipment existed, and we can then use that to inform about potential future eruptions. Magmas contain three main things: crystals, which are made of minerals, the liquid magma, which is the thing that allows it to flow, as well as gas. As a magma cools, it's going to crystallize and form mineral crystals. So we have one crystal that, say, crystallized deeper in the plumbing system of the volcano, and then is transported to a shallower part of the system. The crystal is going to grow a new rim around the outside, which is of a different composition that corresponds to this new environment. So if a crystal is exposed to lots of different environments, we may end up with a crystal that has continually changing composition that looks something like tree rings. So this means that we can use minerals like mini hard drives that are constantly recording the changing environments within the magmatic system. However, thermodynamically, crystals like to be homogeneous. And so what will happen is that chemical elements are going to diffuse into the crystal, chemical elements are going to diffuse out of the crystal. And so, like any bad hard drive, the memory can be rewritten or erased. So this can be like a downside, but we can actually use this to our advantage. So we can use this diffusion process as a kind of stopwatch. So if we know how fast these different elements diffuse through different minerals, we can then model this diffusion process mathematically and match our chemical observations today. And then crucially, we can then link the processes that take place deep within the Earth to actual signals that we can detect at the Earth's surface before a volcanic eruption.